We're going to talk about the difference between exponential and logarithmic functions. So let's start off by having an exponential function y equals 4 to the x power again. And let's say that I wanted to find the inverse function of this. If you recall, finding inverse functions means that the first thing you need to do is switch your x's and your y's. So there, instead of having y equals 4 to the x, I have x equals 4 to the y. And what you want to do is you want to solve this expression for y. As of right now, we don't have an operation that can solve this for y. A lot of people are tempted to take the y root on both sides, but that is not an actual thing for this. So what we're going to do is we're going to introduce a new type of operation, a logarithm operation. The logarithmic operation is the inverse operation to exponentials. So just like multiplication is the opposite of division, and addition and subtraction are opposites, an exponent and a logarithm are opposites. So what we do then is if I have x equals 4 to the y power, to undo that we will take the logarithm of both sides, abbreviated log. Okay, and the logarithm is going to have a base of 4 because I want to undo this 4 power, so log of 4. Log base 4 and then 4 to the y will all cancel except for the y, and then we have log base 4 of x. So that means that the inverse of y equals 4 to the x would be y equals log base 4 of x. So those two are inverse operations of each other. So that means one thing you can do is go back and forth between these two things. If I have a equals b to the x power, we can rewrite this, b is my base, as a power, which means that I would have log base b of a equals x. So these two are interchangeable forms of each other that can go back and forth between one another. I like to think of a logarithm as the power in the exponential equation. So here I have x. My x is equal to log base b of a. Log base b of a all represents the power in the exponential expression. Let's go over now how to graph logarithmic functions. But before we do that, let's recall some of the things about exponential functions. So exponential functions have these specific properties here. They will always go through the point 0, 1, and the point 1, whatever the base is. In this case, it's 4. They have a horizontal asymptote at y equals 0. The domain of exponential functions is all real numbers, and the range is 0 to infinity, and that's because of the horizontal asymptote. Now let's go over what an inverse means. An inverse means that if you have the x values, in an inverse they become the y values, and for the y values of a function they become the x values. So in inverse functions, the domain and the range switch, the x points and the y points switch, and any horizontal asymptote switches to a vertical asymptote because y switches to x. So with that in mind, let's talk about the properties of logarithmic functions. So let's say I have f, and we'll call this inverse of x equals log base 4 of x. So the point of 0, 1 on the exponential function becomes 1, 0 on the inverse, which is log 4 of x. the 0.14 in 4 to the x becomes 4,1 in log base 4 of x. The horizontal asymptote y equals 0 becomes x equals 0. The domain is all real numbers, goes to the range of the inverse, and the range of 0 to infinity becomes the domain of the inverse. So now let's look at how to actually graph those. So the exponential function, you should recall how to graph that, goes through the point 0, 1 and the point 1, 4, and then has the asymptote here at y equals 0, and there's our exponential function. Now the logarithmic function will switch to having the point 1, 0 and the point 4, 1, a vertical asymptote, and there is a log base 4 of x. Okay, one thing to remember, that inverse graphs are reflected over the line x equals y, because all the x's and the y switch. So if the one on the left was reflected over the line y equals x, you would have the one on the right. And there is how you graph logarithmic functions.